universe that's being studied in any given situation. So a system could be just something that you've got inside of a beaker and you're mixing two chemicals together. That could be a system. A system could be a section of the atmosphere that's like causing some weather pattern. A system could be a galaxy. So it's just part of the universe that's being studied in a given situation. A phase is another thing. It is any part of a system which is uniform in its composition and properties. So something in a system, something that you're studying, and it's uniform, so the same in its composition, it's what it's made up of, and its properties. So what we learned about yesterday, chemical and physical properties. Phases in a system are distinct regions, and they're separated from each other by visible boundary. Visible or visible? Yeah, visible. Okay, so an example of this is when a copper rod is placed in water, all the points within the copper rod have the same properties, and all of the points within the water have the same properties. So in this two-phase system, so two phases are our water and our copper. The system is our beaker or whatever is containing this with the water and the copper in it, which is what we're studying. In this system, there is a distinct boundary. Where the copper stops and the water exits. So you got your copper and you've got your water. And there's a really distinct place here where your copper is stopping and your water is stopping. Distinct boundary. A substance is a general term for all kinds of matter that has uniform properties. So I think we talked about substances a little bit in the first set of notes that we did. So it has uniform properties. So some examples of a substance might be orange juice. Orange juice is a substance. It has got uniform properties throughout it. If you drink a little bit of orange juice from the top of a glass, it's going to have the same properties as the orange juice in the middle or the bottom of the glass. A piece of tin is a substance. It's going to have uniform properties throughout it. Diamond. Sugar. Water. So I think we're used to talking about substances as if they are liquids, but substances can be solids, they could be liquids, they could be gases. So it's just any matter that has uniform properties. Homogeneous and heterogeneous substances. Have you guys heard, homogeneous and heterogeneous before? No? Okay. So the way that I like to remember these are both kind of Latin roots. So homo and hetero. Homo is same and hetero is different. So a homogeneous substance is something consisting of only one phase. So only one part of a system that is uniform in composition and properties. So, for example, air, water, salt water even, like what we looked at in our density lab, or a piece of iron. So those are, they have the same properties. It's only one phase, so same phase throughout. Heterogeneous substance is a substance that has more than one phase. The way that you might have learned this before is just without the word phase. Like you might have just learned this with the words like it's a substance that only has one thing in it, or a substance that has more than one thing in it. This is just kind of getting into this terminology that we're going to use in chemistry. So an example of a heterogeneous substance, this is going to sound counterintuitive, but you are a heterogeneous substance, a human. You're made up of blood and bones, all kinds of different matter. You've got gases in your lungs, lots of different phases. A pencil is a heterogeneous substance. Gravel, a salad, a particle is a general term that's used to describe a small bit of matter. So a particle could mean you're talking about an atom or a molecule or an ion. Do you guys remember what an ion is? It's an atom with a charged element. So like copper that has like a 2+ charge, or like chlorine when it has a negative charge. So are ions. Okay. Atoms are the smallest possible piece of something. And that, whoops. Yeah, so the smallest possible piece of something which retains the fundamental properties of that substance is what an atom is. Atoms are made up of other things, right? They're made up of electrons and protons and neutrons. But atoms themselves are the smallest possible piece of a thing that still has the fundamental properties of that substance. So, for example, like a sheet of copper is made up of copper atoms, and each of those copper atoms has the atomic mass and the number of electrons and protons and neutrons as copper in general. So it still has the same fundamental properties of that substance. Okay, so we use spherical models. Models, not metals, to represent atoms. But they're not actually accurate. Models. So, for example, if we look at a hydrogen atom, we might just be looking at a nucleus here that's made up of one proton and one neutron. And then it would have like a little orbital around it with one electron. Do you guys remember doing these Bohr models? Yeah. A lithium, you'd see this as a circle drawn, and lithium has, I think, 3 protons and 4 neutrons. And then when it's neutral, it's got 3 electrons. So you would draw lithium in the past like this. Those aren't actually accurate. Electrons exist in, I'm going to actually just pull up a photo to show you all. Oh, wait. So we're going to look at electron. We're going to look at image. Okay. So this one actually, well, hydrogen is actually kind of spherical. But different atoms have different orbitals where the electrons exist, and the images of them look quite different. Orbitals. Here we go. Okay, so here are a bunch of different images of atoms. So electrons actually exist in these different orbitals in different patterns. And then our nucleus is just like small, tiny in the middle of that. So when we've been drawing these Bohr models in the past, we've kind of been lying to you a little bit, just simplifying. It still helps us make sense of them, but atoms are actually not just those like spherical images you see. They're quite complex, and they can be a lot of different shapes and configurations. Okay. Molecules, they are particles made of more than one atom. And those are held together really strongly by electrical forces. Electrical. Or electrical. Oh, my bad. That's an AL. Electrical forces. Do you all remember the 2 types of molecules that you would have learned about in grade 10? One of them transfers electrons, and then a charge holds them together, and one of them shares electrons. Yeah, covalent compounds are sharing electrons, and then ionic compounds, they actually transfer electrons, and then the charges, the opposite charges, attract. So those are types of molecules that are held together by electric forces. Molecules can be made up of the same kind of atom, or they can be made up of different atoms. Okay. Whoops. Okay, so here's some examples. Okay, so this is hydrogen. Do you guys remember learning about diatomic molecules, diatomic atoms? So there's some things that when they exist just by themselves, they don't just exist as one atom. They're always going to bond together. So hydrogen is one, oxygen is another, and chlorine is another one. So they'll always attach onto another one of the same element. Hydrogen is not going to be found just as hydrogen, like in the air floating around. It's going to find another hydrogen and team up. Some compounds, water, H2O. So this is made up of different types of elements. Hydrochloric acid, HCl. So that's a compound. Okay. Okay, so here's some more information on ions. So ions are atoms or molecules that have an electric charge. Okay, do we remember the different charges of protons versus electrons versus neutrons? So electrons have a negative or positive charge? Yeah, negative. Protons are positive and neutrons are neutral. So depending on the number of electrons that an element has, either just neutrally or by gaining or losing electrons, its charge is going to vary. So because ions have an electric charge, so they've either lost or gained electrons, they will actually conduct electricity. And they get that charge by losing or gaining electrons in their valence shell. So this is where our Bohr models are actually quite useful to describe what's happening. So these kind of models that we draw of atoms that aren't truly accurate, but they're very helpful for describing certain things. So a sodium atom only has got one electron in its very outermost shell. So it kind of wants to get rid of that because atoms are most stable when they have a full valence shell. The valence shell is the most outer shell. Do you guys remember that term? Yeah. So valence shell is the outermost shell. Okay, so sodium is going to ditch that electron. It's going to get rid of it. When it does that, because now there's more protons than electrons, it is going to have a positive charge. It lost one electron, so it's going to have a positive 1 charge. So that's a sodium atom, neutral to a charged ion. So neutral. And then over here, this is a cation because it's positive. So we've got our anions and our cations. This is a nitrate ion. So do you guys remember what multiple elements already forming a compound are called when they have a charge? Yeah. This next. Oh, this one? Sorry, I'll write it larger. Cation. So an ion can either be positive or negative. So when an ion is positive, it's a cation. So our metals form cations because they lose an electron. When an ion is a negatively charged ion, it's an anion. So those are our nonmetals. They gain electrons, so they form anions. Okay, these guys here, when you've got something that's already has multiple elements bound together and it still has a charge, these guys are called polyatomic ions. So that's another type of ion you can have. You can have simple ions, you can have polyatomic ions. And we're gonna watch a video. Forgot to open this up earlier. Okay, so this is in my notes here. Microphone set up. All right. So we're gonna talk about the elements a little bit here, or watch a video about them. Okay, if you're at home, watch this video. All right. So back to this. On to the next page. There's a nice little flow chart here. So matter, when thinking about like elephants and people and chalk and all that stuff, matter. So that's anything that's made up of atoms. There are two things that we can break matter down into: pure substances. So pure substances are made up of elements or compounds that are homogeneous, so they're the same. There are mixtures, and those mixtures, we're going to talk about how to separate those in the next section, and we'll actually do a lab on that. But they're made up, they can be called mechanical mixtures, suspensions, or solutions. And we'll kind of get into what the differences between those are. Okay, these can be, mechanical mixtures are heterogeneous. Oh, these are long words for what the space I've left here. Suspensions are also, I'm just going to shorten this to hetero. Suspensions are heterogeneous. Solutions are homogeneous. I always want to say homogeneous. Elements, so that's just like silver or gold or copper all by itself, are homogeneous because they're made up of one form. And then compounds, same thing. So pure substances are always going to be homogeneous. Mixtures, some of them are going to be homogeneous, like solutions, and some are going to be heterogeneous. Okay. Pure substances. So pure substances are a subset of matter that contain only one type of matter. And have a constant composition. Whoops. Have a constant, that should just say composition. And they cannot be separated. So we can't separate them. There's two subcategories of these. There's elements. So these guys are pure substances. They can't be decomposed into anything simpler. So I cannot take copper and make it into anything simpler. I can make it smaller. I can break it down into like less atoms, but you can't decompose it into anything simpler because it's only one type of atom. I can change those what are they called? Extrinsic things, but I can't change the intrinsic ones. So examples of that, hydrogen, carbon, oxygen gas. So because oxygen gas is made up of O2, so it's two oxygen molecules bound together, you can't break it down into anything simpler because it is all oxygen gas, even though it's two things bound together. Elements can be individual atoms, or they can be molecules of the same atom. So individual atoms, molecules of the same atom. So this is where we get into the difference between compounds and elements. So compounds are pure substances, but they can be decomposed into new types of matter. So they're made up of two or more different kinds of atoms in a definite proportion. Two or more types or kinds. But it is a specific proportion. So like in water, it's 2 hydrogen molecules, 2 hydrogen atoms to every 1 oxygen atom. Compounds, so I know there's a lot of terminology here, you guys. Compounds by definition can only be molecules. If this would actually be a really good section or a really good unit to make flashcards for. So I actually do have a ton of flashcards up here. If anybody wants to, you're welcome to take one of these or like many of these, because there's a lot of terminology in this unit 3 that we're doing. So if you're a person who like thrives on flashcards, this would be a good unit to make them for. What's that app that people use? Quizlet? Quizlet's another good one if you want to have something on your phone. But yeah, we're gonna be referring to a lot of these definitions that we're learning right now. So I would strongly recommend kind of reviewing those frequently. All right, decomposition. Do you guys remember decomposition reactions from last year? Some people, yes. Okay, so decomposition, that is when one kind of matter comes apart and it forms 2 or more kinds of matter. So how do we actually get elements to decompose? Electrolysis is one. So electrolysis involves having a positively charged thing and a negatively charged thing. So like we can use batteries for this, and running an electric current, and that can decompose compounds into multiple kinds of matter. Heat, decompose compounds, but will not change elements. So it doesn't actually change the elements, but it does decompose compounds. So it's still like you could have water decomposing, but it's still going to be hydrogen and oxygen. It's not going to be different elements. So electrolysis, I was talking about, that involves passing an electric current through a substance, and that causes it to decompose. I actually have got a cool demo that I'm going to show you guys afterwards instead of doing this video. So we'll come back to that. I just need to go grab a battery and a couple things. So we'll do a demo on that later. We're going to come back to that. But it's really cool. So we can also say that compounds are matter. Oh, demo. Demo instead. If you guys want to watch that video later, feel free. Okay, we can also say that compounds are matter that is put together by combining elements. but not all combinations of elements are compounds. So this is like those actually, this is something that if you took philosophy, you would talk about different strategies of logic. So compounds are matter, but not all elements are compounds. So all compounds are made up of elements, but not all combinations of elements are compounds. So an example of that, hydrogen and oxygen can be mixed together in any proportion, and you get a mixture of colorless, odorless gas. If you ignite that mixture, it explodes. Some of the hydrogen and oxygen combine to form water again. If you decompose that water produced, you'll find that there's always twice as much hydrogen gas as oxygen gas. So because hydrogen and oxygen gas can be mixed together in any proportion, we would be making something that's not a compound to start with. We would have a mixture. So that would be a mixture. But then once you would ignite that and explode it, any water that you got out of that would be a compound because it's made up of equal proportions of hydrogen and water. It's kind of a wording thing. Okay, law of definite composition. So this is a law. We talked about like laws, theories, and hypotheses before. So this is something that defines a specific thing. Mixtures can have almost any composition that's desired. But compounds have a definite composition. So definite just meaning same proportion of different elements, whereas mixtures can have like any composition. I can throw a bunch of oxygen and nitrogen into a scuba diving tank. I don't know if there's any other gases in there. I feel like there are, but I can throw those into a diving tank. They need to be in a specific proportion, but you could throw them in any proportion, and you'd have a mixture. But compounds like water, they've got a definite composition: 2 hydrogens to 1 oxygen. Okay, so example, H2O, water, is always 2 hydrogens to 1 oxygen. There's another law. The law of multiple proportions is 2 or more compounds can be made that have the same elements but in different proportions. So this is to do with like different compounds, different compositions of compounds. So hydrogen and oxygen can be combined to make all sorts of different compounds. So H2O, when there's a 2-to-1 ratio of hydrogen to oxygen, that's water. Do you guys know the composition of hydrogen peroxide? There's a great joke about this. Yeah, that's hydrogen peroxide. Does anybody know the hydrogen peroxide joke? Okay, guys, I'm like not great at telling jokes, but we're gonna go for it anyway. Okay, so a chemist and their friend walk into a bar, and the waiter comes over, and the chemist is like, "I will have some H2O, please." And then the friend is like, "Yeah, I'll have some H2O too." and then they get their drinks and the friend dies because it was hydrogen peroxide, and that's poisonous. Right? You're welcome. Okay. There's many more where that came from. Do you guys know Sierra Haziza? Have you guys been following her jokes of the day? Yeah. So every day she's putting up a new earth science joke on the board in earth science. So yeah, I don't know where she's putting them, like on TikTok or something. I have no idea. But anyway, you should ask and follow her because they're really funny, and like she says them and they're even more funny than just reading them. Okay, anyway, mixtures. They contain two or more kinds of mixtures, kinds of matter that have separate identities. So they don't have constant composition because you can vary the amount of the different substances. So an example would be salt dissolved in water. So you all saw in our different salt waters, there were like multiple different proportions of salt and water. So those were different mixtures, or alcohol dissolved in water. So for example, in Canada, we can have like fairly high proportion of alcohol dissolved in water in like, I want to say like soft alcohol beverages. I don't know what the correct word for this is, but like beer. We can have a fairly high amount of alcohol dissolved in that. But in Utah, it's like 2% or something is the limit. So alcoholic beverages are mixtures. You can have different proportions of those dissolved in water. That's maybe not the best example, but okay. And we're gonna watch another YouTube clip here. Oh, whoops. Yeah. Okay. I know I'm throwing a lot of information at you guys today. Okay, so solutions. So these are the three subcategories of mixtures that we had on our flowchart on the other page. Solutions are mixtures that are the same throughout. So that's homogeneous, and does not scatter light. So all types of matter can be mixed together to make a solution. Pop is an example. Air is an example. Alloys, so metals melted together are alloys. Suspensions are a little bit different. So suspensions are heterogeneous mixtures. And they are not the same throughout. They scatter light when they're mixed. And it looks the same throughout, but will settle into layers if you leave it. So has everybody made a salad dressing and it's had like oil and water in it, or like oil and balsamic vinegar or something, and they separate? Okay, so when you mix suspensions, you can make them look like a homogeneous substance, but then they will settle out later. So like Salad dressing is a really great example that we see often. Well, I don't know, we may see them often if we like salad. Tomato juice. That'll separate into layers as well. But if you shake it up, you can make it look homogeneous, but it's not. Okay, so colloids are temporary suspensions. So these guys are called temporary suspensions because they actually won't settle into distinct layers. And the example that they showed of this was milk in that video. So colloids are a subset of suspensions. We're not going to talk about these too much, but there's a few different types of them. There's foam, so that's gas dispersed in a liquid. Aerosols are liquids or solids dispersed in gas. So you guys might have seen like aerosol cans of spray paint or something. So those are aerosols. Emulsions are liquids in another liquid, so like mayonnaise or milk, or solids, butter and cheese. They require something called an emulsifier in order to keep the substance suspended. Or gels, which are a solid dispersed in a liquid. So like gelatin, like Jello, is a gel. What an appropriate name they chose for it. Mechanical mixtures are heterogeneous mixtures. Heterogeneous. In which different types of matter must be physically mixed. So heterogeneous mixtures, different types of matters have to be physically mixed. So like cereal floating in your milk is a mechanical mixture. Ice in your soda, mechanical mixture. Soil, blood, actually. You've got a lot of different components to your blood. There's this nice little chart here that shows some other things like homogeneous mixtures are I don't know why I keep on having alcoholic examples, vodka, steel, air, rain. Okay, last little section here, and then we'll do some questions. Okay, let's watch this solutions versus mechanical mixtures. Okay, so that is solutions and mechanical mixtures. All right, so solvents are the component of the solution which is in greater quantity. So generally when we're talking about solvents, we're usually working with water. Water is always the solvent when it's in a solution, but sometimes there might be something else. So when salt dissolves in water, water is the solvent. An aqueous solution. So this is something we're going to talk about quite frequently. Aqueous, we are going to abbreviate as AQ just for future reference. Solution in which the solvent is water. So anytime you've got a solvent of water, we've got an aqueous solution. And then the solute is the thing that is in smaller quantity. So in that example, in that video, the salt that she was dissolving in the water was the solute. So above example, salt is solute. Okay, so a solvent is any substance that dissolves the solute particles during the formation of a solution. Most solvents are in a liquid state, but sometimes they can be in a gas or solid state. And then a solute is a substance, so like salt, that is added. Why is this blank so big? Added to the, added to a solvent. The words solute and solvent, I get mixed up constantly, to form a solution. Okay, another just quick abbreviation. I will sometimes abbreviate solution as that, SOL with a little apostrophe and an N. The solute can exist in all three forms, so solid, liquid, or gas of matter. And then here's just a nice example of a mixture, or solution rather. We've got salt as a solute, water as a solvent, salt water solution. Okay. I'm gonna just, I think that covers it. I'm gonna not watch this video. Any questions about those differences or any of what we just went over? Okay, that was a ton of information. I know. I'm gonna let you guys take a 15-minute break now. So let's come back at, I'm just gonna hit stop on this really quickly.